how are you? First of all, I will introduce myself. I'm Arya Devi. I'm dealing with chemistry. Do you love chemistry or you like learning chemistry? Actually, chemistry is an interesting subject. Everything in this world are related to chemistry. The food we eat, the dress we wear, the environment in which we are living, everything is connected to chemistry. Okay, without any delay, we are moving to the topic. Today we are going to discuss about amorphous and crystalline solids under the unit solid state of grade 12. So the topic is amorphous and crystalline solid. Before moving to the topic, we should know what a matter is. A matter is anything that has a mass and takes up space or has a volume. And this matter can exist in three states: solid state, liquid state and gaseous state. In solid state, the particles are tightly packed. In liquid state, the particles are loosely packed than the solids but tightly packed than the gases, which is represented in this figure. And in gases, it's clear that the particles are very loosely packed than liquids and solids. So today we are going to learn more about the solid state. This is the intermolecular structure of a solid, or how the particles of solids are arranged. From this, it's clear that the particles are tightly packed in a solid. Now we are moving to the characteristics of solids. The solids have a definite mass, volume and shape. The intermolecular distance of the particles in the solid are very short, but the intermolecular forces between the particles are very strong in solid. Their constituent particles have a fixed position and can only oscillate about their mean position. The solids are incompressible, that it cannot be compressed, and rigid. The solids can be classified into crystalline substances and amorphous substances based on the nature of order present in the arrangement of their constituent particles. A crystalline solid is usually consists of a large number of small crystals, each of them having a definite characteristic geometrical shape. The arrangement of constituent particles in a crystal is ordered and repetitive in three dimensions. If we observe the pattern in one region of the crystal, we can predict accurately the position of particle in any other region of the crystal, however far they may be from the place of observation. Thus, crystal has a long range order, which means there is a regular pattern of arrangement of particles which repeats itself periodically over the entire crystal. The crystalline solids are anisotropic in nature, that is, some of their physical properties like electrical resistance or refractive index show different values when measured along different directions in the same crystal. This arises from different arrangement of particles in different direction. Sodium chloride and quartz are typical examples for the crystalline solid. Some solids like glass and rubber and some other plastics do not form crystals when their liquids solidify on cooling. These type of solids are known as amorphous solids. Okay. The arrangement of constituent particles in such a solid has only short range order. In such an arrangement, a regular and periodically repeating pattern is observed over short distance only. The regular pattern are scattered and in between the arrangement is disordered. The amorphous solids are isotropic in nature, That means their properties such as mechanical strength, refractive index and electrical conductivity etc. are same in all directions. It's because there is no long range order in them and arrangement of particles is not definite along all the direction. Hence, the overall arrangement becomes equivalent in all direction. Therefore, value of any physical property would be same along any direction. Okay, this is the arrangement of crystalline and amorphous solids, or the arrangement of particles in crystalline and amorphous solids. Okay, here there is a long range order for the arrangement of particles, but here it is only a short range order. This is the crystalline quartz and amorphous quartz glass. Okay, while the two structures are almost identical, yet in the case of amorphous quartz glass, there is no long range order. So this is about the crystalline solids and amorphous solids. Now this is about the isotropic and anisotropic, which we discussed before. Some properties of solids like refractive index when measured from different directions will result in different values of crystalline solids. This is called isotropic nature of the crystals. Amorphous substances do not show this property, hence they are isotropic in nature. The amorphous substances are known as pseudosolids or super cold liquids. This is because of the ability of amorphous solids like glass to flow. The amorphous silicon is used to make the photovoltaic cell because of this ability, and the glass tend to become milky in appearance over a long period of time, and this is also because of the slow crystallization of glass. Clear? Now we are moving to concentrate on the crystalline solids. The crystalline solids can be classified into 4: molecular crystals, ionic crystals, network crystals and metallic crystals. The molecular crystals can further divided into non-polar molecular crystal, polar molecular crystal and hydrogen bonded molecular crystal. This is non-polar, polar and hydrogen bonded molecular solids. First we are going to study about the non-polar molecular solids. The non-polar molecular solids are soft, they are insulators of electricity, they have very low melting point. The intermolecular forces which is present in the non-polar molecular solids are dispersion or London forces. The examples are argon, CCl4, H2 and CO2. Next classification is polar molecular solids. They are also soft, they are also insulators of electricity, they also have a low melting point. Here the intermolecular force present in the polar molecular solids are dipole-dipole interaction. The examples are HCl and SO2. The next classification is hydrogen bonded molecular solids. The hydrogen bonded molecular solids are hard. They are also insulators of electricity. They also have a low melting point. Here the intermolecular force present is hydrogen bonding. The example is H2O, that means ice. Okay, now we are moving to the characteristics of these types of solid. The first one is molecular solid, which can further be classified into non-polar, polar and hydrogen bonded. The particle or the constituent particle in the molecular solids are molecule itself. The bonding or the attractive force in non-polar molecular solid it is dispersion force. In polar molecular solid it is dipole-dipole interaction. In hydrogen bonded molecular solid it is hydrogen bonding, and the examples are also given. The next type is ionic solid. From the name itself, it's clear that the constituent particles are ions, and the bonding or attractive force that present here is Coulombic or electrostatic force. The examples are NaCl, MgO, ZnS, CaF2, etc. The third one is metallic solid. The constituent particles here are the positive ions in a sea of delocalizing electrons. Okay, and the bonding force is metallic bonding. The examples are Fe, Cu, Ag, Mg, etc. And the last type of solid is covalent or network solids. The constituent particles that are in the covalent solids are atoms, and the bonding is covalent bonding, and some examples are SiO2, SiC, etc. Clear? So today we discussed about crystalline solids and amorphous solids. Thus crystalline solids can further be classified into 4: molecular solids, ionic solids, metallic solids, and covalent solids or network solids. These molecular solids can further classified into non-polar, polar, and hydrogen bonded. Hope you are clear. Thank you.